All right, let's talk about the cloud. That magical thing that makes everything from streaming your favorite show to last-minute online shopping just work. Today, we're going to pull back the curtain and look at the real physical building blocks that make it all feel so instant and so reliable. Let's jump right in.
You know the feeling, right? You click a link, and then you wait. And you wait. You're just staring at that little spinning circle, that wheel of death, thinking, come on, why is this taking forever? Well, that little moment of frustration, that's actually where our story starts today.
See, that delay, it's not random at all. It actually comes down to two things: straight-up physics and smart design. It's a massive problem, one that the biggest tech companies on the planet have poured billions, literally billions of dollars into solving. So right now, we're going to unpack exactly how they cracked that code.
Okay, so to really get the solution, we have to start with the problem. Let's rewind and look at the most basic setup you can imagine. Just one single server, trying its best to handle requests from the entire world.
So, imagine you've just built this awesome new app. You're excited, you go out, you buy a server, and you stick it in a data center somewhere in London. You flip the switch and you're live. It feels great, right? Simple, straightforward, but, and this is a big but, it's also got two huge fundamental flaws. Problem number one is something called latency. Now, if you're sitting in a coffee shop in London, your experience is amazing. It's super fast. But what about your friend in Sydney? For them, the data literally has to travel on cables under the ocean, halfway around the planet, and then all the way back. That trip takes time. That physical delay is latency, and it makes your app feel sluggish and broken for them.
And then there's problem number two, availability. What happens if someone trips over the power cord to our one server in London? Or, the whole building has a blackout? Poof, our app is just gone. It's offline for every single person on Earth. Availability hits 0. That's what we call a single point of failure, and it's a disaster waiting to happen.
So let's recap where we are. If you're in London, the speed is great, low latency, awesome. But for someone in Sydney, the latency is terrible. And for everybody, everywhere, the availability is just plain bad. One little accident and the whole thing goes down. This setup is it's a non-starter for a global app.
All right, so how do we fix this mess? I mean, we can't exactly change the speed of light, right? But what we can do is get way, way smarter about how we build this thing.
Let's look at how this evolves. Okay, step one was our single server. We know that's no good. So for step two, what if we add a second data center but still in London? Well, that's better for availability. If one goes down, we have a backup. But it does absolutely nothing for our poor user in Sydney. The latency is still awful. So that brings us to step three, and this is the real game changer. We put data centers in London and in Sydney. Now we're talking. Users in Europe get a fast connection from London. Users in Australia get a fast connection from Sydney. We've tackled both latency and availability.
But, and here's the massive catch, this amazing setup sounds great on paper, but who on earth can actually afford to do this? We're talking about buying land, building massive, secure buildings, dealing with power grids, cooling systems, hiring a huge team of people to run it all in multiple countries. The cost is just astronomical.
Yeah, trying to build your own private global network of data centers is, well, it's pretty much impossible for a startup. Heck, it's a monumental challenge even for giant established companies. So, does that mean having a fast, reliable global app is just a pipe dream for the rest of us?
Well, no, not at all, actually, because this is the moment where the hero of our story swoops in. This is where the cloud completely changes the game.
And here's the best part. All that incredibly hard, expensive work, it's already been done. Companies like Amazon, Microsoft, and Google have spent decades and hundreds of billions of dollars building out that exact global network we were just dreaming about. And now, they basically let us rent a piece of it.
I mean, just look at the sheer scale we're talking about here. This isn't just a few spots on a map. Microsoft Azure has over 60 of these global regions. AWS and Google Cloud, they each have more than 30. They have literally blanketed the entire planet with this infrastructure so that you and I don't have to.
Okay, so in cloud speak, these big geographic locations, our London, our Sydney, those are called regions. And a region is the cloud's brilliant answer to that latency problem we talked about. It's really that simple. You put your app in a region close to your users, and bam, they get a fast experience.
But it gets even smarter. Inside each one of those regions, they don't just have one data center. They have multiple, totally separate data centers. These are called availability zones, or AZs for short. And when I say separate, I mean it. They have their own power, their own cooling, their own networking.
They're designed so that if a disaster takes out one, the others don't even blink. This is the cloud's answer to our availability problem.
Just a quick heads up on the names, because you'll see this stuff everywhere. All the big players, AWS, Azure, Google, they all call the main geographic area a region. Easy enough. But for the data centers inside, AWS calls them availability zones, or AZs. Azure and Google just call them zones. It's the exact same idea, just a slightly different name. Don't let it trip you up.
So, when you put it all together, by tapping into this ready-made network of regions and zones, you are basically handed a set of superpowers. Seriously, these are capabilities that just a few years ago were only available to the absolute biggest tech companies in the world.
I mean, think about it. With just a few clicks of a mouse, you suddenly have a global footprint. You can deploy your app all over the world. By picking the right regions, you kill the latency problem. By spreading across multiple zones, you get incredible availability. And on top of all that, you get this amazing ability called horizontal scalability, which is just a super powerful, flexible way to grow your app.
And this idea is so important. The old way of doing things was vertical scaling. Think of it like buying a new, more powerful laptop every time your old one gets slow. It's expensive, and eventually you just can't buy a faster one. But the cloud way is horizontal scaling. Instead of one giant, expensive machine, you just add more, smaller, cheaper machines as you need them. You can have hundreds, even thousands, spread across the globe. It's way more flexible and basically has no limits.
So really, if you remember just one thing from all this, let it be this. Regions and zones aren't just some random features on a price list. They are the absolute, fundamental building blocks of the modern internet. They're what makes it possible for anyone, from a single person coding in their bedroom to a massive global company, to build an app that's fast, reliable, and can reach the whole world.
And that really leads us to the most exciting question of all, doesn't it? This incredible, globe-spanning infrastructure. It's not some far-off dream anymore. It's right there, like a utility, ready for you to plug into. So, if a global audience is literally just a click away, what problem are you going to solve first?